We're going to start a section called redox reactions. Redox reactions involve the transfer of electrons. You need to know some definitions before we start. Oxidation is the loss of electrons, and the way we remember that is, I'm going to write oil, oxidation, loss, reduction is the gaining of electrons, and so we say oil rig. Reminds me that oxidation is the loss of electrons, whilst reduction is the gaining of electrons. Oxidation is loss, reduction is gain. You need to know that an oxidizing agent helps something else to be oxidized, so it gets reduced, and a reducing agent helps something else to get reduced, so it gets oxidized. And it is important that you realize that oxidation and reduction must happen as pairs, and you must have an oxidizing and a reducing agent. In other words, they have to be linked up, because when you're transferring electrons, electrons have to go from one thing to the other thing. They have to leave somewhere and they have to go somewhere. They can't hang around in limbo. A substance which is oxidized is a reducing agent, and a substance which is reduced is an oxidizing agent. In other words, it helps the other thing too. We need to assign something called an oxidation number. Reduction and oxidations always take place together, and we need to check that our oxidation numbers balance. The oxidation number is the measure of the richness of electrons of a compound, and it's quite easy because it correlates completely with charge and valency. So let's look at something like water. If I'm going to use water, I'm going to say the hydrogen is in group 1, so it has a valency of +1 or charge of +1, and the oxygen is in group 6, so it is -2. It would gain 2 electrons, hydrogen would lose 1 electron if it bonded. Now, you may say that doesn't add up to 0, but actually that's the oxidation numbers. But when I'm doing my calculation, I will go +1 times 2 gives me +2 minus 2, because there's only one of them, equals 0. Every substance, if it's neutral, must have an overall oxidation number of 0. Any element, if it's on its own, has an oxidation number of 0. So I2 is 0, sulfur 0, oxygen 0, iron on its own 0. When I assign oxidation numbers, if I am dealing with a group 1 element, it is going to have an oxidation state of +1. Any bonded element from group 2 is going to be +2. Chlorine, fluorine, bromine, iodine, in other words the halogens, are -1, and oxygen when it's bonded is -2. Don't forget your polyatomic ions. They will have exactly the oxidation state of their charge. So if it was NO3 minus, the oxidation state is -1. Sometimes we need to look at the whole radical on its own or the whole polyatomic as a group, but sometimes we're going to look at each element in there on its own. It will depend. I'm setting out the rules first, then we will practice and see how they apply. Elements alone are always 0, and from there you can work out most other. So we assign oxidation numbers. Let's take a look at this one over here. We have got H2S. We don't care about balancing numbers at all when we are doing assigning of oxidation numbers. Sulfur's on its own, so it's 0. I kind of do this as a puzzle, not necessarily in order. +1 on the hydrogen, -2 on the oxygen, -2 +1. Working out the overall number over here, we can see that +1 + 1 -2 is 0, as it should be. Sulfur on its own is 0. Here we've got -2 times 2, so it's -4, and I can work out that that sulfur is +4. Here I have got +1 + 1, so it's +2, and I can work out that this sulfur is -2. Notice that sulfur's oxidation state can be different. Now I consider that the arrow is my dividing line. If I take a look at sulfur, it has changed from -2 to 0. Hydrogen hasn't changed. Oxygen hasn't changed. From -2 to 0, and from another element from +4 to 0. So what I'm going to do is I am now going to say that this sulfur was negative, now it's neutral, so it has lost electrons. The loss of electrons is called oxidation. I don't write the last word down. That was my thinking. When I go in this one over here, this sulfur has gone from +4, positive, to neutral. So it has gained some electrons. That's not what I write down. I write down reduction. The oxidation number goes down. You've got reduction taking place. Let's look at it. My oxidation number went from +4 to 0. That's going down as a number, and I've had reduction. When my oxidation number goes up, I have oxidation that has taken place. So here, from -2 to 0, that is oxidation taking place. So in this case, the hydrogen sulfide, H2S, was oxidized and therefore is a reducing agent, whilst simultaneously my sulfur dioxide, SO2, was reduced, and so it is an oxidizing agent. Let's try this one. Magnesium is all on its own here, so it's 0. Sulfur, 0. Oxygen, when it's bonded, -2, -2. Magnesium is in group 2, so it's +2. Let's check, does that come out to 0? Yes, it does. +2 -2, 0. Here we have -2 times 2 is -4, so we're going to put in a +4 over there, and overall that is also 0. Let's see what has happened. Magnesium has gone from 0 to +2, so it has lost electrons. What is the loss of electrons? Oxidation. And this sulfur dioxide, the sulfur has gone from +4 to 0, so it has become less positives. It has gained electrons, so therefore that is reduction. In grade 11, all you're going to have to do is you're going to have to assign oxidation numbers and tell me what got oxidized and what got reduced. So let's take a look at one of these examples. Remember, we could say that chlorine is more powerful than, let's say, iodine, so it would toss it out from its salt. The chlorine joins with potassium bromide to form potassium chloride and bromine. Let's do the oxidation numbers. 0, 0, +1 for potassium because it's in group 1, -1 for chlorine because it's in group 7, -1 for bromine because it's in group 7, +1 for potassium because it's in group 1. What has happened? We have got chlorine going to chloride, so it has gained electrons. It's become more negative, so the gaining of electrons is going to be reduction. And over here we have got the bromine going from -1 to 0, so it has lost electrons, and that is oxidation. And I could do that for all of those. Here's another example. When I have got a more reactive metal, it will displace the less reactive metal from its salt. So let's take a look at that example. We have got zinc on its own 0, iron on its own 0. The sulfate ion is -2, so iron metal will be +2. The sulfate ion is -2, so zinc metal will be +2. Let's see what has happened. Iron has gone from +2 to 0, so it has gained electrons. What do we call the gaining of electrons? Reduction. And then we've got zinc, which has gone from 0 to +2. It has lost electrons. What do we call the loss of electrons? Oxidation.